Hi guys, welcome to mycngguy.com. We're going to be taking a look at a new conversion that we're going to do today. Every time that we're doing a new conversion on a different style of vehicle that's a really popular and common car, we're going to try to show you a video of what we're going to do on a layout and to help you out. The Ford Taurus, this is, one of the #1 selling cars in the United States. I'm going to show you how easy it is to do a conversion on this car. So when you're looking at your car, just take a typical layout. Before I do a conversion, I like to take it to the car wash, clean it up. That way when you're touching all your wiring harnesses and all your components, they're nice and clean, grease free. When I'm soldering, there's not going to be grease everywhere. So that's what I do, is I take and clean the car first. Alright. So on your preliminary checks as a mechanic, you're going to check your ignition wires on your customer's car or your own car. You're going to check the spark plugs and make sure that they are wiring correctly. One thing that I noticed on this customer's car on my preliminary checks before I did anything, his connector is broken on his connector there. So you want to make a note of that on your customer's cars, that way it doesn't come back and bite you. So what we're going to do is look at our components here. This is going to be included in our V6 kit. You see we have the two 3-cylinder rails, the parts accessory kits, the ECU, the accessory kits that go with the ECU, the temperature sensors. Here's the regulator, and here's the wiring harness. It may look big, but it is really, there's nothing to it. On this car, we're going to supply connector adapters that go from the EV1 to an EV6 injector, which is what this car has. That is an optional upgrade. You don't need it, but if you want to add $60 to your cost, we can include those adapters for you. That way you don't need to cut these, and all you have to do is plug them right into your car. Now when you buy a kit from My CNG Guy, I'm not going to show you all of it, but this is our calibrator. This is unique to us. We're the only ones that have this. When you buy a kit from us, the experience that we have in converting our own cars, we are going to calibrate your injectors for your vehicle. When you receive your kit from My CNG Guy, you're going to notice that there's going to be a line here on your injectors. Do not ever touch these. And if they do come out of alignment, I personally mark these so you know where to put them back to. Okay? So on your preliminary checks on your car, when you're looking at a Ford, what you're going to want to look for is you're going to come over here to your gas tank. If you have a yellow gas cap, you have a flex fuel vehicle, or if it says E85, that has an alcohol content monitor built into the gas system. Those vehicles are more difficult and complex to convert. Ford also puts FFV right there. You want to be careful of those cars. Alright, so in the computer, what we're going to do as a technician, you're going to come in your car and you're going to hook up your scanner. First thing you're going to do is you're going to go to State OBD Check. You're going to look at your monitors. You want to make sure that all monitors show OK and that nothing is included. If anything says included, that means that there's a problem with the vehicle and that has to be fixed first. Alright. Then you're going to come into your pending codes. Okay, that has to say pass, and read codes. If there's any problems with the vehicle, whatever happens on natural gas will be expanded tenfold. Alright, the next thing you're going to do is you're going to go into your view data, and you're going to check all of the monitors. Now, I'm going to go to entire data list. So in this, I've already done the preliminary checks on this, and I made sure all the sensors are working correctly. The important ones that you want to pay attention to are this ST frame rate, the short term and long term. That's what those stand for. Now, before converting this car to natural gas or touching anything, the fuel trims are plus 28% on the long terms, and that is really, really ultra high. That normally will turn a check engine light on the long term. So that means that it's running really, really lean. I don't know why it's running that lean. The long terms are only showing 0%, which is flawless. The closer to 0 this is, the better the car is running. So those are very, very important. You have to make a note of the long-term fuel trims, because that's the average. And if this average goes over 10 to 14%, it will trip a light on for running lean. Then the next thing you're going to check out is you're going to look for an alcohol content monitor in this list. If it has an alcohol content monitor, you're going to have a very difficult time converting this to natural gas, any vehicle. And the reason why is the more alcohol that your vehicle detects, it'll change the map of the original fuel system in your vehicle, and that will change the settings that you did in your natural gas system. So that's why that is important. So since everything checks out on this car is ready for a CNG conversion, and the customer wants a custom thing made right here in the dash compartment. I'm not going to be working on that. I would suggest putting it here. It's just a little bitty hole you'll drill, and then if you ever wanted to change, let's say you wanted to change your stereo, this whole unit gets replaced in this Ford. So if the customer didn't like a hole, you can just replace the whole thing. If you ever wanted to put an aftermarket stereo in it, this whole thing gets replaced. So it'd be like brand new. So personally, I wouldn't be worried about it, but that's where I would suggest, because this is removable, it comes right out, you can put the hole here, and it's easily viewable for everybody and not in the way. But the nice thing about this kit is you can put your gauge anywhere you want, because you just drill a little bitty hole and just stick it right to your dash. That's it. I'll see you when this car's completed. Alright, so welcome back. So I'm going to decide to mount the regulator right here. It's a little tricky on room. So I'm going to mount the regulator right here, and I'm going to show you the details about this regulator, what makes it really neat. Okay, and then the computer is going to be mounted right here. Let me come out. So I'm going to mount the computer right there. The reason why is because you want to make sure that everything's going to be easily accessible. All of my computer data information system is going to be running through this wiring harness right here before it goes to the ECU inside the car. So this is where all my taps are going to be made. As you can see right here, there's an oxygen sensor wire. That oxygen sensor right there comes up and will meet there. My injector harness is going to go underneath here. Now I'm going to have to remove this intake plenum here, which won't be a really big deal. It's just a couple bolts. I'm going to make a special bracket for this to mount on. So I'm going to be removing this manifold to drill the injector ports for my nozzles, and also to access the injector wires in the back to quick splice. Now there's three options that you can do, or two options that you can do. So we can either just use a quick plug and plug right in, or we can cut the wires to the injectors over here. It is going to be a cleaner install if you do that, but it's very time consuming. You're going to add about an hour to 2 hours to trace the wires, the colors, make sure you're doing the right one, and solder and wrap it up and make it look really nice. So let me show you about this regulator here. What makes this regulator really special is, here, let me put it in the vise. So I'm going to mount this in the vise here. What makes this regulator really, really cool is this piece right here that comes off. Now, this can be mounted in so many different ways because of the way that this device here is configured. So once you mount your pressure sensor in this, the fuel line is going to come in here. Now this can spin any way, in any direction, because this can be in the way sometimes. So this, as you can see, can rotate in any direction. Alright, now I only have one hand. So this can unbolt right here like this and can come off. Now you can flip this around. Alright, So now you have more options for this spinning around. Now what's cool about this one from my CNG guy is this O-ring right here. Now when you put it on here, there's different regulators that you can buy from other companies that have a crush washer. Now those crush washers, if you ever remove this, it'll leak. And let's say you messed up and you have to move this just a little bit. Well, you're gonna have to get a new crush washer on both sides and make sure that it's tight, really, really tight, to make a seal, or else you're gonna get a little bit of leak. But this one, because of these O-rings right here, you're not gonna get any leak, and you can move it any way you want without it leaking, and it'll be very safe. So you can do this here, or let's say you need to flip this around. Okay, this thing can actually flip the other direction. Okay, you just undo this bolt here and flip it upside down. Now you can move this over here to this side if you need that room. Alright, and all of these seals are either replaceable, they're all rubber, so they're not going to leak. I mean, you have so many different mounting options with this regulator. That's why I like it. It runs our 4 cylinders and V6s extremely well. Alright, so on the regulator here, while I'm at it, the temperature sensor is going to be mounted right there. I'll go right there, screw in. When I'm done marking everything and getting it done, I'll put that together. Fuel outlet is right here. This is the little nipple for the vacuum, and this is the pressure adjustment. As you can see, turning it to the right will decrease the amount of pressure this puts out, and turning it to the left will increase it. So there's the water inlets. So it's everything's pretty much self-explanatory on it. Very universal regulator, can be mounted in so many different ways to get for your specific application. Alright, thanks for watching again. Hi, welcome back for this portion of the video. In this portion I'm going to update you with my progress. So right here I have the high pressure regulator mounted with the lock-off valve under there that you can't see, and the fuel inlet, and there is a pressure gauge under there. Here's the temperature sensor outlet. The computer is mounted right here. Made a special bracket for it. It's nice and sturdy. Will not interfere in any way with the factory upper motor mount, which is designed to flex up to about not quite that high. I mean, if this engine was in really bad shape, and it still wouldn't contact the ECU. It's not in the way of anything. It's nice and clear. Hood will shut. Here's my injector rail, all 6 cylinders, and you don't see the injector nozzles in there yet. The next part of the video I will explain how to calibrate them for each vehicle, and this portion is already going to be calibrated. These do not come from the factory calibrated. They were all different measurements inside, and I used my device that I had specially made for us to set them all at a 50mm stroke. That is what the power output will require for this engine, and I will show you what I'm going to do next time with the wiring harness. That will be laid out. The wiring harness will go here. This is going to be my intercept point for all of the signals. So next time you'll see a lot bigger mess, but the hard parts are mounted, so that way you can see where the wiring is going to go and how long you need to make the cable lengths, and you can go from there. Alright, I'll see you next time. Alright, for this next part we need to decide what we're going to drill the holes out to match this nozzle calibration to our engine. So what we're going to do is we're going to look at this AC diagram in the book here, and we're going to find out the power output to determine the nozzle diameter. So this Taurus 3.0 liter puts out 155 horsepower. Divide that by 6, we come up with 25 horsepower per cylinder. So we're going to go with this size here, which is 2.4 to 2.6 millimeter. So I'm just going to drill that out to 2.7 is the closest that I have, so that's okay. So this is what the nozzles will look like. This is stock here to the right. The nozzle that I drilled out to the appropriate size is on the left, and this is how you do it. All you do is you put your nozzle in the vise there, take your drill bit, stick your drill bit in the top, make sure it's straight, and fire away. That's it. Alright, see you in the next part. Alright, so in this portion I'm going to show you the next step that I'm going to do is drilling the nozzles for the intake manifold where the fuel will be delivered into the intake stream. As you can see, I've pre-marked all of the spots where I'm going to be drilling and tapping these nozzles. And what I did was I just used the piece of the mounting bracket for your fuel injector, and as you can see, then I made the hole. That way it'll be the exact same on all of these cylinders. Okay, and so I removed the manifold on the Taurus because I need to get to these injectors to put the tap in there, or we have a quick connector that'll splice into these injectors without me having to cut the wires and mess around with them. So I removed them to drill the manifold and to access these back factory fuel injectors for my electrical harness. So I'll show you what I'm going to do here. What I'm using is a drill tap, and there's a drill bit piece at the first part, and then there's actually some threads back here to thread it out. So all you're going to do is you're just going to take your manifold. Let's see if I can do this with one hand. Here I go. Okay, so now you can see that the hole is drilled and tapped in one step. Those are the shavings that came out on this side. Let's see what came out on the inside portion. So that's what came out on the inside portion when I tapped it out. That was the outside, and that's what came through on the other side. So that's why I removed this manifold on this car. Alright, so I'm just going to do that on all the rest of them. Now what you're going to do is you're going to apply, they say a Loctite, a red Loctite on these threads. So I'll apply that to these, and then because of that drilled and tap in one step, it's ready to thread right in. And there you go. So once I put the red thread locker on there, then that portion will be done. Then I just got to reinstall this manifold and go from there. What was really cool about this Ford was these are a reusable silicone seal. So what you have to do is when you pull this out, you got to make sure that it's still flexible. It doesn't have any cracks in it, and it's not hard. If it's hard and has cracks, just go buy some new ones. They're only a couple bucks at AutoZone. Alright, I'll see you next port. Alright, so this is an update on my next adventure here. As you see, I've made a mess of the wiring harnesses coming into the engine compartment, and what I'm doing is I'm toning out the individual injector wires. You can see that I've already found bank 1 injector wires, and I've labeled them. Starting bank 2, and what I've done is I've found the wire color that coordinates over here to the injector. So you can see that red on the Ford is all the same on all injectors, and I found the different color wire, and this one on injector number 2 is a brown and blue, which I found over here. Now, to make sure that it is the correct wire, what I've done is I've hooked up my ohm meter, and I have it on tone. I'm just going to go into the wire itself, and you can hear the tone, and I've verified that that's the wire. These are the wires that I'm going to be marking off and taping, and then I'm going to be cutting. I have to cut because the individual injector adapters aren't going to work on this because of this harness cover is on the back side of this engine. So in the long run, my install is going to be really super clean, very professional looking, but it's just going to take a little bit more time, as you can see. And so that's how you're going to find your wires, and this is the mess that it's going to look like, but I'll show you later what it's going to look like when it's all cleaned up. Hi there. So I've just completed my wiring harness. These are my wiring harnesses that are going to go to that plug there from the controller. They're all done. Solid wires on our harness goes towards the factory petrol injectors, and the wire coming out of this harness with the solid goes back to the computer, the factory computer. And that's it. So you see that I soldered and ink shrink them, and this is the tool that I'm using. That's my soldering gun. So that one works really good. And so now that I've got the injectors done, now I need to do the oxygen sensor wires. I gotta find them in this harness, and an RPM, and power, and that's it. Then I'll be good to go. Alright, thanks. Alright, so before I button up the back end of this motor, I have to install the coolant line taps, which we have in two sizes, depending on the size of coolant lines you have. This is the kit that you'll have. You'll come with 4 of these and 2 of these hose clamps. So all you're going to do is you're just going to find your coolant lines. There's going to be 2 sets of them. You see I pinched off the lines there, and there's also another one over there, so that antifreeze doesn't all run all over the place. Slide your hose clamps in. Looks like that one will be the right size, and just put that back in there. Slide your hose clamps on, which are right here. Tighten them up, and then your coolant line will come over there, plug right into the top of that port right here. Put a hose clamp on there, and I'll be doing the same thing to this coolant line right there. And I've already got them done into the regulator. They're already tight, hooked up, ready to go. So that's how you hook up your coolant line. That's it. So one of the most difficult things you may find yourself running into is how to get your wires into your engine, from your engine compartment to your passenger compartment. What I've done is divided up all of the wires in my wiring harness. These ones will be left outside the engine compartment, and these ones I need to run in. This is your this one will be the switch wire for your power, and then your positive, hot, and ground are in this harness, and then this yellow wire is going to be for the OBD2 adapter. I'm going to run that inside, and then this harness here, this is for the switch. So I need to run all these wires into the engine compartment, or to the passenger compartment. So I did find this plug installed in the car, and it's really hard to see, but so I pulled the plug out, and it leads in here. It's really difficult to see. There's the ABS, or the airbag module, and right behind it is a hole. And I'll run all them wires up through there, and then the switch will be mounted up here, and then over there on the other side will be where the rest of the wires will go, and we will supply power taps to go into power distribution box right there. Right there. So that's my next project. Alright, in this part I have reinstalled the manifold. I've hooked up the injection lines. You can see the little S-curve. The reason why they're like that is because you cannot bend these or kink these lines. These hoses transport your fuel, and they're curved like this because of how close they are to the manifold. But when I get to this injector here, the length is a little bit long. So when you're measuring these all have to be the exact same length, and you have to go with whatever one's the longest length. The rest have to be the same. You cannot shorten any of these. They all must be the same length. And they also cannot be more than 20 centimeters long. 15 millimeters or centimeters is great, but anything less than 20 is really good. Cannot go over 20 centimeters though, at all. Otherwise you'll overlap injection times and your idle will be really, really rough. So that's that part. Alright, I'm just going to update you on my progress that I'm making so far. I'll show you what I've been working on. So one of the portions you're going to be working on is your vacuum lines. This one right here, as you can see, I've marked it with pink on this hose connector. That way the customer will know that if he ever disconnects the line where these are going to go. Pink will go to pink for pressure, and white's going to be or vacuum, and white's going to be for the pressure. You see what I did is I ran the injector control wires. You can see they're all marked with different colors, and in the harness I've written all the corresponding wires where they go to the injectors. But all my wires are going to go underneath the plenum here. The vacuum hose, the pressure hose, and the temperature sensor wire, they're all going to be routed under there. I have a lot more wrapping up and finalizing, but as for right now, I'm still plotting everything out and planning and just doing one thing at a time. And the vacuum hoses, you can see I wrapped underneath here and kept it away from the alternator and the accessory belt and anything that might pinch or cause a problem. So you can see the pink hose that was over there on the vacuum comes into this T, one goes to the regulator, and the other side is going to come up and go to this map sensor. The pressure line comes straight up and goes right into the map sensor. There's going to be a plug that plugs into it, and I'm not finalizing this because I still have about 4 more wires to find in that main harness before I wrap that up and finish this loom. And the gas line, I don't really like this, but this car was really, really tight, not very much room. But the gas line comes here. I have it going into the filter, which is directional. It is a lifetime filter. You only need to clean it with brake cleaner every 10,000 miles. I have it right here, so it's nice and easy to service. And then I have it coming right up here. I installed this 90-degree fitting here. This is available at your parts store. This is it's actually for your water fittings in your house, but it's pressure rated, and it's really, really thick brass. It's for the shark bite lines, the plastic PEX lines, and it fits perfectly in all of the components that we have for our rubber hoses. And then it goes right into the injectors. So that is what I'm doing so far. It looks like a mess, but the more progress I make, the cleaner it gets, the nicer it gets, and the easier it gets. So I'll keep you updated for next. Alright, in this portion I'm going to show you some advanced wiring techniques, how to find your wires. Now, there's my mess of wires again, like you've seen before. This is my Bluetooth adapter. I can attach this, and I don't have to have wires going around, so that's what that is. But right now what I'm looking at is this wire that I'm attached to. This is a 2000 Ford Taurus, and this tan wire with the yellow wire, that is supposed to be the signal wire for the RPM. So what I'm going to do is I'm tapped into there. This pigtail goes over to the brown RPM wire, and I'm going to show you how to figure out if that is correct. Normally you'd go off of the coils here, but as you see, there's no black wire for a ground. These are all hot, so you can't attach on this Ford Taurus the RPM wire to the coil. So what you have to do is you do have to go right here. This is the only place to get the RPM on this car. Now to verify that it is correct, I'll go over here to the computer and I'll show you how to set it up. So as you can see right there, the RPM is going between 680 and 700. You can see my injection timing is all correct. That's all detected. Now the car is a 6-cylinder and the RPM signal is going to be a 6-cylinder. So you can see that that comes up correct. Now we do have the option for an RPM from a camshaft sensor, and I'll show you where that is in case you can't find this wire. And then the RPM signal is 6.2 volts, and I'm getting a lot of static noise off this wire, so I have the signal filter turned on. Now I'll show you why we set the RPM signal voltage up. As I have my voltmeter set there at DC, and see if I can do this with one hand. Okay, as you can see, I'm getting about 6.2 volts out of that wire. So that's why I set the voltage up, to be able to read at that voltage. And then we can come up with the correct RPM signal. Now, so I verified it here, here, through the voltmeter, through that other wire, and I'll also verify it on my computer, my handheld scanner. And we are at, see that, 700, and it's ranging on this scale here. That's why it's ranging on the computer through the software program. Okay, so that's how you determine that. Now, the next one I'll show you how to do is the oxygen sensors. So on my handheld scanner, you see that I have these isolated so that it's fast, and you see the voltage changing there. Okay, I'm going to go over here, and I've already predetermined the wire colors. I wrote down all of the colors on bank 1 sensor 1, and then bank 2 sensor 1. I identified all their wire colors. Now up here, I've already worked on cars enough that I know which wires are which. And so I knew which wire it was, so I went right to them. You see that green connector there? That's the oxygen sensor for bank 1. And you may be wondering, how do you know it's bank 1, sensor 1? Well, bank 1 is going to be the cylinder that is facing the front of the engine where your alternator is. Whichever cylinder is forward more, that's bank 1. That's cylinder 1, bank 1. See, and this one's obviously really far back here, so that's going to be cylinder 2. Now, so I already got the RPM identified, so that's where I'm going to be tapping in there. So let me go over here and show you guys how to determine this. So in the main engine wiring harness, there's going to be a set of colors. Mostly the cars have 4 wires, and the signal wire is going to be the wire that is going to be different from the other side, but also that it'll have the same type of color coordination. So you have gray, light blue, and then the other side was red, light green. Now see, all the other ones kind of make sense. It's not going to be the same on both sides. So what I've done is I have my gauge here. And you see that light, that means that it's running rich. Okay, I'm on bank 1, sensor 1. So you can see on my gauge here that when that light comes on, I'm also rich the exact same time on that sensor. That's how I know that I'm hooked up to the correct sensor. And then I'll do the same thing on the other side, and when this is lean, this light will be off. And I also verify it through my voltmeter. My voltmeter will show the same voltage that my gauge here is showing. This one's hooked up to the factory computer. So that's how you verify that you're hooked up to the right oxygen sensor wire. So everything comes through here. That way we're going to make sure that the install is nice and clean. Alright, so we have that. Let me show you this wiring inside the car. And go ahead and shut that off now that I know the RPM's the right wire. So I ran all of the wires through this little hole that was already pre-drilled and had a grommet in it, and nothing went through it. And I'm going to be cleaning up that wiring harness later, but the hardest part is trying to find out where you're going to run your wires, how you're going to do it, how you're going to make it clean and everything. So this customer did not want any holes drilled in their car at all, which is kind of difficult. But so this customer is really religious. They don't smoke, so they don't need a cigarette lighter. And this is where they wanted their fuel gauge, but they wanted me to make a bracket that went here and drilled up here, which I think is weird because they didn't want any holes drilled, but I'd have to drill more holes here to mount a bracket and look goofy. So what I did was remove their cigarette lighter, and I'm going to put their gauge here. Yeah, dang it. Let's see. Let me see if I can get all these wires in here. There we go. Alright, so their gauge is going to go here, and I'll make it look pretty later. But basically, it covers up that whole hole. Alright, so I'll just double side tape it there, and the customer will still be able to have full access, full view. It won't look weird or goofy, and they'll get what they want. And they also still have their 12-volt outlet. So I hope they don't complain that I took their cigarette lighter out. Now I also did that because you remember I ran the power wires through. So the constants I will hook up to the cigarette lighter wires. Now what's cool about this is it already has a built-in fuse underneath the engine compartment, and it's at 20 amps, which is how many amps this one was set with. So it has a good ground, a good clean power, and I'll be able to make that install nice and easy. And the only wire I'll have to run is the switch wire, the one with the black stripe, and I'll just have to find that somewhere that turns on when you turn the key on. That's not a big deal. And then I still have the yellow wire ran through here, and I'll leave it taped up until they decide if they want to run an OBD adapter that'll attach to their factory computer. And I make that really easy for the customers at my CNG guy, because I will pre-wire it and pre-terminate it for you. So all you have to do is plug it right in and to your OBD port there, and just run one yellow wire to this yellow wire. That's it. I'll make it nice and easy for you. But I hope you guys are understanding what I'm doing. It looks like it's a mess, but it's not too bad. It's just trying to route the wires, find out where you're going to put them and how you're going to do it, and making sure you do it right, so when you wrap everything up, you don't have to go back and redo it. So alright, so let's come back out here. Okay, so all I'm going to attach is the brown wire, and then the purple and the purple gray. Okay, so where'd that brown wire go? The brown wire somewhere right here. Okay, so these are the three last wires that I have to hook up. Now you'll notice that they're all different. You have a purple wire, a brown wire, and a purple stripe. It's a gray wire with a purple stripe. And now their position is very, very important. If you come over here and you look at the instruction manual, you'll see that my instructions are hard to read. But the violet gray goes to sensor 2. That's why it's important to make sure that you find sensor 1 and sensor 2, because sensor 1 goes with the 1, 3, 5, and 7, and sensor 2 goes with 2, 4, 6, and 8. So you have to make sure that you get the right banks on the right side. Otherwise, one bank, it doesn't know how to figure out if the left bank is lean or the right bank's lean, because you got them switched. So make sure you read the instructions, and put this violet one on bank 1 sensor 1, and that one corresponds to 1, 3, 5, and 7, and the violet gray goes to sensor 2, or bank 2 sensor 1, and that corresponds to 2, 4, 6, and 8. Now that's only good for oxygen sensors that read between 0 and 1 volt. If you have a sensor that reads 2.5 to 3.5 volts, it's different. It's called a UEGO, and you hook up both wires to just one sensor. But one wire, the violet goes to one side and the violet gray goes to the other side. The instructions here are in your program, so make sure you figure out and use your voltmeter and find out which sensor you have. Alright, I will see you next time on my next long-winded sermon. Oh, also, I'm sorry, I forgot. You see this wire on Fords? Fords, as far as I know, are the only ones that do this. This wire here, if you open up your harness, doesn't matter if you have a Ford V10 or Ford 4-cylinder, if you see a set of wires, 2 wires, with aluminum foil wrapped, that's your crankshaft position sensor. Ford does that to isolate the noise so it doesn't pick up any noise from any kind of interference from any of these other wires, so it gives you a nice clean signal wire going to your factory computer. This system can read this, so be careful when you tap into here, but if you can't find your RPM, you can also go through this wire here. It's easily distinguishable. You'll be able to find it really quick. But make sure you buy the aluminum foil tape at your hardware store and recover this up. That way you don't mess up your factory Ford system. Alright, that's it now. Alright, on this part I'm going to show you what I did with mounting a switch. Down at my Ace Hardware I found this little plug. It's a little plastic plug that fills holes. I drilled this out using a 5/16 drill bit right there. Alright, now that's the hole size you need. Let's see if I can do this to put this switch in. So then what you do is you put the wires in that hole, feed it through, a little difficult with one hand. Anyway, it slides in really nice and easy. It's going to be really tight. What I'm going to do is I'm going to glue this switch to this little thing. Okay. Now, so what you do, so I'm going to come down here to the hole, and when I'm ready, I'm going to just put that in, and it'll pop right into the cigarette lighter, like that. Did you hear it click? And that's it. Okay, so that's how I'm going to mount this customer's thing. This is an idea. The easiest way is just to drill a hole somewhere in your dash and put that through, and you're good to go. So what I'm going to do is I'm going to take that long stretch of cord and feed it right up through that hole. Like that. Okay, so then I have that. And you can see I got a lot of length, so I'm just going to cut quite a bit of it off. I'm going to hook up the power wire and the ground here to the old cigarette lighter, power and ground. Run this one over to the fuse box over there. We'll supply you with the tap. And I just got to key on and off some sources and find an ignition source, and then I'll be there. So the next time you see me, everything will be completed, and I'll show you what my final installation looks like. Alright, this is the moment I've been waiting for. This is a completed installation on a 2000 Ford Taurus 3.0 liter. So this is it. Go ahead and take a look at everything that I've done. This is what it'll look like. I think the last time you saw this, it was a pretty big mess. That's where the computer's at. This is the map sensor, the regulator. Underneath there you can see the fuel gauge. You can actually see it, so we'll be able to see the fuel pressure. It's a really tight fit, but didn't really have a whole lot of options. That bright plug you see there, that's for the data cable. The relays right there. Everything is wrapped up real nice and neat. Fuel hose comes down and around. I got it in a 90-degree bend going in. There's the rails. You'll see that I have some paint markings on each of the injectors. What I did was, bank 2 is always red on a natural gas system. If you ever see a harness with red, it's bank 2, always. So I marked that as bank 2, which is the front side. And bank 1 is marked with white. And then I wrote down what corresponding cylinder they go with, so if ever it gets taken apart, I know where it goes. The intake manifold vacuum is right there. That's where it should be, right behind the throttle body. Everything's nice and neat away from the throttle cable. So that's the completed installation there. That's what it's going to look like. As you see, everything is nice and neat, just the way the car came. So I'll go inside and show you my progress in here. Okay, so inside the car, here's my switch. It is glued to the little thing. This is completed with the little sound buzzer, and everything is heat shrinked. You can see the tube, everything's nice and neat. I have the power connection soldered. This one is for the switch. Everything is heat shrink tube there. Everything's nice and neat. Okay, so this is all we're going to do, is we're just going to put this back together, and here's snap in there, and that's it. Fuel gauge is mounted just as the customer wants. No holes drilled. No holes been drilled in this customer's car. That was their specific request. So the only two wires that you're going to see I have left, I just have to run this over the fuse box under the brake pedal. And this yellow wire that I was telling you about, this is going to hook up to our OBD adapter. The customer decided to upgrade, so this yellow wire coming out of the OBD adapter here just connects together. This part here, if you order it through us, and I'm going to ask you some specific questions, but this OBD adapter I will pre-wire based on your car. So all you have to do is plug it in. That's it. Just attach this wire and plug this in, and that will allow your computer, your natural gas computer, to communicate with your car's computer and keep all of the settings accurate and increase your drivability. So the next time you see this, we're going to be doing a tuning portion, and I'm going to show you how to tune it. Alright, hello and welcome back to mycngguy.com. This will be the final portion of this video. The car is completely done. I'm going to show you all the final steps on your final tuning and your final installation. On this car, we have the gas gauge right there, fuel lights, everything's wrapped up, everything's done. In the fuse box right there, I have the ignition wire that triggers this system. It's the red wire with the black stripe going to one of those fuses in there. And when you crank the car, that wire does not lose power while cranking. It stays on. That is very, very important with this kit. Alright, so the car's running on CNG right now. I've already driven it, warmed the car up. So what I'm going to do is I'm going to show you the parameters of the system in the laptop. So we'll go in the car where it's nice and quiet. Alright, so I hope everybody can see this. I'm going to start over here on this right side. Your gas pressure should be at 2 bar while running on natural gas. That's where that setting should be there under gas. Your map sensor here should be the exact same number that you also see in your computer on your handheld scanner. This is the injection times there. As you can see, we're about 5 milliseconds over here on your petroleum injectors, and over here we're about 6 to 7. At idle, you must be within 1 to 2 above your petroleum injectors. If these numbers over here are the same or lower than these over here, then you need to send your injector rail back and tell us what the problem is, and I can recalibrate them. I calibrated this car at 50 millimeter stroke, and I was 1 millisecond under our petroleum injection times, which means that I was injecting too much natural gas. So I had to turn them down to 40 millimeters with this, and you can see that it made that difference and put me right in specification. Alright, you'll know that you've got your system settings correct when you read the correct, these are in Celsius, but if I look at my factory computer's times or put a laser gauge on there, that's the number you'll see. And then also my oxygen sensor voltage, you can see is correct, and I did verify that multiple times. The battery voltage is correct, RPM is correct, all 6 injectors. We are on natural gas. Now I'm going to go through it so you can see what the proper way that your car should be running. This is what it should look like on your screen when you're running on natural gas. Now I'm going to go through the settings with you and show you what you need to put in your settings. So in the program, you're going to go to the first screen you'll go to is car parameters, and I've already shown you this. You need to put how many cylinders your vehicle is. That's very important. That tells this portion how many cylinders to put in. Okay, so if you have an 8-cylinder and you only see 6 or 4, then you need to come up here and put that in. Number of RPM per coil, the 6 cylinders, that's going to be different for each vehicle. You just need to get your right RPM signal correct. That has to be correct. When you rev it up to 4,000 RPM, it better read 4,000 RPM on here. If it reads anything else, your system will have major problems. So you can see what I put in here. This is a standard engine type. Your oxygen sensor. The sensor readings that I was getting was 0 to 1 volt, and so that's what I put in here was 0 volt means lean. The UEGO voltage and full range, those are for, let's say if you have a Toyota or Dodge, Hemi, those vehicles use a UEGO. And you'll know that because the voltage will range from 2.5 to 3.5 volts. Alright, now this car, the type of injection is a standard. Renix is for Jeeps, the Jeep 6 cylinders. Alright, so we have all that, all of our readings are correct, so we know we did a good job. So the next screen you're going to go to is gas controller settings. Switch over temperature. This on all vehicles must be at 54 degrees Celsius, and there's a reason why. Switch over threshold is where it will turn over to natural gas. This is a high idling car, so when it's cold, so I want it to be at 1100 RPM. Your switch over time is cylinder switch over. This is how smooth it transitions. If it transitions rough or too soon, you can change it there. And switch over to petrol. You should leave this at 0 degrees Celsius. That's where our temperature range is on these gas rails that you get. Minimum gas RPM, you can leave that at 0 unless your car dies or has problems. You can turn this up, and if your vehicle hits that RPM, you'll just switch over to natural gas or your petroleum. I had to do this with a Hemi under 900 RPM. I had to switch him off, and then it will, once he hit above that 900 RPM, it would just switch back over to natural gas, and he had no idea. It transitioned really nice. Max gas RPM, this is important. Every single vehicle, no matter how good of an install you did, must be at 3400 RPM. Natural gas does not burn past 3400 RPM. Your vehicle will not run. You'll burn up your valves, cause catalytic converter damage. What this is going to do is once you hit 3400 RPM, it will transition you over to normal fuel flawlessly. You'll not know the difference, and your vehicle will run perfect. Your catalytic converters will be perfect. Your engine will be perfect, so no damage will happen. And these two settings, you can just leave them alone for the load and the pressure air time. Now this is important. If you're going to use CNG, you need to make sure it's on CNG. Now I also have a lot of people that ask me about the fuel level indicator. Their indicator down there has the wrong reading. Well, our sensor is a WPGH1. If you bought the kit from my CNG guy, it's right there. If you bought it from somewhere else, you can try these other ones, and I don't guarantee results, but you can manually enter in these voltages here if you want to change them as well. Okay, so that's what we use, is a WPGH1. And the injector type, choose, if you have the blue injectors from my CNG guy, then you're going to use the ACGI-AC01 3 ohm. Okay, if you are using our premium Barracuda injector, then you're going to choose the HANA 2000-2001 green option in this system. Now, injection heating, if you live in a cold climate such as Utah or Wyoming or North Dakota, you're going to want to put that on. That will work the injectors and heat them up so they last longer. Gas injector settings, this is important. The reason why I told you need to make sure that your oxygen sensor is on the correct bank for the correct injectors is because you have to program this. My injectors, number 1, 3, and 5 are on bank 1, and 2, 4, and 6 are on bank 2. Alright, our reducer temperature sensor is CT-LM-5K. This is extremely critical. If you get that wrong, the temperature setting over here, right there, will be incorrect, and you will have injection problems. It'll think that it needs to lean it out or enrichen it. These got to be right. The gas temperature sensor is CT-LE-4K7. That has to be correct. Alright, so we're done with that. And in the advanced portion, we don't really need to do anything unless you have a Mazda. You can read the instructions under documentation up here if you have a Mazda. The instructions are there under Stag 300 Premium. But everything else here you don't really need to worry about unless you have some kind of problem that this lists. That's pretty advanced. You'd have to give us a call for that. Alright, so next thing I'm going to show you is the auto calibration part. Now, I've already got the car warmed up. I've been verifying that the codes, there's no check engine light. Alright, I've been driving the heck out of this car on CNG, but no check engine lights, I promise you, have come up. And this is my computer that I've been monitoring. My short-term and long-term fuel trims have been very correct. You can see they're a little bit higher than I would want. We're riding right on the threshold. Once they start hitting 10, the check engine light will come on for running too lean. So to correct that, you're going to want to say, well, how do you fix that? Well, you buy the OBD adapter. I did not install it yet on this car. I wanted to see how well it would run without it, and look how good it runs without it. So if you want these to be absolutely incredibly nice and your car to run really good, buy the OBD adapter. $60. It's super easy to install, just one wire, and then plug it into your OBD port, and you're done. So this is pretty dang good for the computer not able to correct itself and communicate with the car. Alright, so what I'm going to do is I'm going to show you what a calibration should look like. I'm on natural gas, so I'm going to switch off. Okay, you notice those dropped off. Now, air conditioner is on. If that is left on, you're going to run into major calibration issues. It'll run really bad. So switch off your air conditioning, your radio, and your lights. Make sure your lights are off. No loads on the car. Okay? Once that's done and your injection times are stable and everything is correct on here, see the O2 sensors are working, RPM is stable, gas temperatures are correct. Alright, now we're ready to calibrate. So then hit start. So this is going to go in and it's going to predetermine what the factory's injection times maximum and minimums are. It's recording those numbers there, comparing them with its oxygen sensor readings there, finding out what its maximum and minimums are here, and then it's going to duplicate that over here, and it's going to keep them in tune with the way your factory system is running. So we'll give that a minute. It's the injection parameter transfer. Now, if your injection lines are correct and you drill the nozzles out to what the paperwork says, this transition should be perfectly smooth. Car should not die or have any problems. If your numbers over here are getting too wild, you need to give us a call and tell us what's going on, and we can try to help you out. If we need to recalibrate the injectors, just send them back and we'll recalibrate them. I don't mind doing that. It makes the car just run perfect. So you can see we transitioned over there, and we are 2 numbers away, which is perfect. Okay, there's our transition to all 6. So you see the numbers are going to stabilize a little bit. We're about done. It's going to take a little bit of time at this point before it'll be done, but so there you have it. Once that's completed, then you'll know what how your vehicle is going to run. It'll give you any kind of error messages there, and you can see our oxygen sensors are ranging perfectly now. You can see that the times are stable. The car is idling very smooth. So it's going to let it run like this for a little bit and see how well it runs, and it'll build a map. I'll show you that map there. I'm hoping this gets done here really quick so you're not just sitting here for a while. Oh, we're done. See that? Now, this is a perfect example of the way it should look. Right there. Adjust map multiplier on the road and assign injectors to appropriate banks. That part that I showed you earlier is how you do that. And I've already done that, so okay, we're done. Now, the reason why you know that it completed successfully is when it builds a map on here. This number will range from 0 to 2.4. The higher that bar is, basically the worse you're going to get. It absolutely should be between a little above 1 to 1.4. If it is too close to 1, that means that your injectors are too big and you're going to overlap your injection times. That's bad. Anything from 1 and below is bad. You're going to run way too rich in an idle. The higher this is, the leaner you're running and the more drivability problems you're going to have. So from their manual specifications, anywhere from 1 to 1.4 is absolutely perfect. 1.6 isn't too bad. If you start getting up here, we're going to need to upgrade you to a bigger regulator and better injectors. Alright, so if you're over 1.6, give us a call, and you're going to need to buy a little bit more expensive components. And they are more expensive for a reason. Alright, so there you have it. I hope you guys enjoyed the video and have learned a lot from this installation. And be sure to check out our kits at mycngguy.com. This training video is being provided to our customers from mycngguy.com. And keep in touch with us on YouTube, or feel free to give us a call at any time. Thanks.